this topic, we need to revise trigonometric functions. So let's go through this first. So in this topic, you're required to know how to draw the graph of sine. Notice that instead of y equal to sine x, I use it in terms of t, where t stands for time, x stands for the displacement. Let's draw this, -1 and 1, put pi on 2, etc., and then draw the graph. Okay, so you get pi, 3 pi on 2, and 2 pi, and then put this is the graph of sine x. So x equals to sine t. So you put the dots. Okay, like that. 3 pi on 2. Okay, so that's your graph of sine. Draw the graph of cos as well. Alright, draw the graph. Okay, good. Draw this because this will be useful later on. Okay, good. Let's move on. Solve the following equation. So this equation, whenever the equation is 1 or -1 or 0, the answer will be on the graph, which is the boundary angle. So sine t equal to 1, that's when equal to pi over 2. So you can just read it off the graph. Sine t is 0, it's going to be here, 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 here. Okay, so you write 0, pi, 2 pi. T. Okay, sine t is -1 at 3 pi over 2. So these are the times, and do the same with cos using the graph. Okay, let's do that. Cos t equal to 1 equal to 0 or 2 pi. Cos t is 0 at pi over 2 or 3 pi on 2. Cos t is equal to -1. That's at pi. Okay. All right, good. Once you know how to use the graph to solve these simple equations, you should learn how these special values, which is on the reference sheet. We have to look at the triangles, but it is recommended you memorize them off by heart, because on the reference sheet it's in degrees, this is in radian. So write them down. Half, this is 1 over root 2, this is root 3 over 2, like that. And then the other one, this is cos pi on 6, which is root 3 over 2, 1 over root 2, and half. So I really recommend you to memorize these. Okay, memorize. Memorize. It will help you to do the question. Okay. All right. Okay. Think about these values. Will be useful later on. Okay. Let's move on. What's the next bit? Next bit is solve equations. So solve the first one. Is in the first or the second quadrant with the related angle pi over 6, because if you do shift sine of half, give you 30, which is pi on 6. To find the actual time, you do pi over 6 in the first quadrant, or you do pi minus pi on 6 in the second quadrant. So the answer will be pi on 6, 5 pi over 6. Do the same for the other two. Okay, look at the quadrant, look at the related angle. Yeah. Sine t is negative 1 root 3 over 2, so you do the related angle first. So shift sine of positive, which is pi over 3, negative in the third and the fourth quadrant. And then you go t equal in the third quadrant will be pi plus pi over 3, or 2 pi minus pi over 3, which is equal to 4 pi over 3, or 5 pi over 3. Okay, like this. And then the answer to the next two, I'll just write it down, you can just check later. This one will be pi over 4, so 3 pi on 4. And what's the other one? 3 pi on 4 and 5 pi on 4. And this one will be half, will be pi over 3 and 5 pi over 3. Okay, good. All right. So you need to know how to solve equations. That will be important later on. Next, we have to review some of the formulas you learned in extension 1, the double angle formula. So hopefully remember, this is 1 minus cos 2t on 2. This is 1 plus, continue on, 1 plus cos 2t on 2. So basically, you double this angle. So notice I deliberately write not in terms of theta, in terms of t, because now everything are time. Okay? And then you also have this auxiliary angle formula. The auxiliary angle formula is when you have a sum of sine and cos, that could be written as r cos, not r cos, r sine t plus alpha, where r is the square root of a squared plus b squared, tan alpha is b over a. And the same thing for the other three. So if there's a minus here, you have it minus instead, but everything else is the same, right? And if it's a cos, you start with cos. So therefore, it's going to be, if it's a minus, it's a plus. If it's a plus, it's a minus alpha. Okay? Note these formulas. Not on the formula sheet, so you have to memorize these. Okay, so this is a quick review of basic trigonometry. Then we're going to learn about simple harmonic motion. Simple harmonic motion. Alright, already? Okay, let's move on. Simple harmonic motion. So we've got these equations, special values, and graphs that you have to learn. All right. All right, let's move on. Okay, so to understand simple harmonic motion, let's look at a simple example. So you have a graph presented in front of you with this equation, x equal to 3 sine 2t plus 1, where x is in centimeters, t is in seconds. So we have graph x against time. So the graph has been drawn, and what we're going to do is to show the position of the particle at these times, every pi over 4 seconds. So at the beginning, it starts at 1. That's where it starts, right? That's the starting point. Start. And then what happens after pi over 4 seconds? You move to the position 4, isn't it? You move to 4, right? And then after that, it goes back to 1 at pi over 2 seconds. So that's t equal to 0. And then this is t equal to pi over 4. And then next is pi over 2. It goes back to this point again. Goes back to this. At t equal to pi over 2. And then the particle goes down to -2 at t equal to pi over 3 pi over 4. So it moves down. And then moves back up again, isn't it? So basically you can map this point. So let's use a different type of pen. No, not this one. Okay, so basically I map it here. This is like here, and then here. Okay. So I map the position of the. So basically the particle is actually moving in one dimension. Start from 1, goes up to 4, goes back to 1, go back to -2, then go back to 0. I'll go back to 1 again, and then repeats. Repeats to goes to 4, and then goes to 1, and then goes to -2, goes back to 1. Okay, so we see this type of motion periodic. It repeats, so do it once and then repeat again, and it oscillates between 2 points. So it oscillates between 2 points. So what you do is the 2 points you oscillate between, these are called the extreme of the motions. So the extreme of this motion are 4, the highest, and the lowest is -2. So you say the extremes are 4 and -2. These are the extremes of the motion. Oh, this one disappears. Okay, all right, let's try again. So you go x equal to 4 and -2. Okay, all right, find the center of the motion. The center is the middle. So to find the center for this example, you just have to average the two numbers. So you go x equal to 4 plus -2 divided by 2. That will be 1. 1 is the center. Okay, 1 is the center. And the center position is also another word for that. It's called the equilibrium position. Okay, equilibrium position. Okay, so next we're going to look at the amplitude. The amplitude is defined as the distance between the highest displacement and the center. So that means the highest displacement is 4, the center is at 1, so the amplitude, which is A, 4 minus 1, which is 3. Okay. And then the period is how long it takes to repeat. So it takes pi seconds to repeat, isn't it? Right? Before you repeat, so period is pi from the graph. And then we'll find the initial position of the particle. Initial position is 1. Starts from 1. Okay, so we'll write all this down because these are important part of this motion. So we say the above motion is called simple harmonic motion, SHM for short. Simple harmonic motion refers to any motion that oscillates, another word for oscillates, vibrate, between two fixed points periodically. So you have to see two things. It must repeat periodically, and it must vibrate or oscillate between 2 points, 2 extreme points. These are called simple harmonic motion. So examples of such motions are tides, spring, waves, and many others. So now what we're going to do is we're going to, actually before we do that, let's interpret the answers we've got. The extreme, the center of motion, the 1, this is the center, isn't it? That's the center. And you can see this is the amplitude. Okay. And then the period, which is pi, is equal to 2 pi divided by 2, which is pi. Okay. All right, let's differentiate to find the, thank you. All right, let's continue. Examples of motion. So now we're going to find acceleration. So we started with x equal to 3 sine 2t plus 1. And then what we do is we're going to differentiate to find velocity, and then differentiate to find acceleration. So differentiate once, you're going to get 6 cos 2t plus 1. Differentiate again, you get negative 12 sine 2t. Actually, there's no plus 1 after that. Okay, good. So write this down, and then you can factorize the negative 4 out, which is equal to negative 4 times 3 sine 2t. And why do I do that? Because 3 sine 2t is equal to 3 sine 2t is equal to x minus 1. So that can be replaced by x minus 1. So you can express acceleration in terms of displacement. So acceleration is negative 4x minus 1. This is a very similar concept to exponential growth. So when we have the quantity as e plus a e to the power kt, then the first derivative can be written in terms of itself, q minus e. Whereas in the simple harmonic motion, the acceleration can be expressed in terms of displacement. Okay. All right, we'll come to this equation later on. Notice that this number 4 relates to this number 2. So basically, any simple harmonic motion can be expressed in the form of x double dot equal to negative n squared x minus c, where c is the center of the motion. Okay, any question? All right, let's move on. C is the center of motion. Center. N is the, see that 4 here, is that 2. Yeah, 2 square, N is 2 square. All right, okay, let's move on. Okay, so the next bit is we're going to see, so that's summarized in the box here. X double dot equal to negative n squared x minus c. So basically what's n? N is related to the period. So in that case, the period, this n here, is period equal to 2 pi over n. This n is related to the period. So this equation tells you the period, tells you the center. So now what we do is we're going to look at more broadly we're going to generalize the formula for simple harmonic motion. So if the amplitude of the motion is a, and if the center of the motion is 0, therefore the extreme will be a and negative a. These are the extremes of the, so the particle will move between these 2 points. Okay. On the other hand, if the center of motion is c, then the extreme will be c plus a, c minus a. Okay. Okay, good. So now let's look at the, so basically before we looked at this formula, a equal to a, x equal to a sine nt plus c, which is the same one we looked at before. This one here, a sine nt plus c. So in this equation, if I substitute t equal to 0, let's see what we get. So x equal to a sine 0 plus c. Sine 0 is 0, which is c. So when you use this equation with sine in it, the motion starts at the center of the motion. On the other hand, if you use the equation with cos and substitute 0, you'll get a cos 0 plus c cos of 0 is 1, so A plus C. So the motion starts from the extreme of the motion. So if you use cos to model the motion will start from the extreme. If you use sine to model the motion, it will start from the center. So we'll note the difference between them. All right, so this part is quite important, so that's why I draw a box around it. Okay, good. All right, so what if the motion doesn't start from the center or the extremes? Then we have an extra plus alpha in there, right? So if it doesn't start from the extreme nor the center, the equation is changed slightly with a plus A. Okay, so let's highlight this. And this will also satisfy this differential equation. Acceleration is negative n squared x minus c. And this allows us to quickly check if a motion is simple harmonic. Okay, let's look at animation to see how would this actually help us to model the position of the spring. So spring is an example of simple harmonic motion. So these are all different spring at different position, at different time. So I've got animation, which is the spring has been stretched. So as I play this, the position can be modeled. So the end of the spring starts from -2. The equilibrium position is x is 0. So if I press play, it will go up and down. So model two positions, right? So as it goes up, go to the maximum displacement, go down, etc. So let's look at it more slowly. Let's go back to this bit. So the motion starts from -2, and then after 1 second, it goes to, oh, it's a bit different. Period should be 4. Now it should work. Okay, let's try again. So a bit slower. So after 1 second goes to the middle, and then after 2 seconds goes to the maximum, 3 seconds, 4 seconds. Okay, let's go back to so basically we can see that the sine cos graph can be used to model the position of the mass of the spring. Okay, like that. Let's draw that. We'll come to this diagram later on, but now we're just going to answer questions about displacement and time and velocity. So at different time, the position of the spring can now be modeled by this curve, by this trigonometric curve. Okay, let's move on. Okay, let's look at an example. A particle is moving in simple harmonic motion according to this equation. Find the center, period, amplitude, and extremes of the motion. Okay, center. This is the center. 2. Amplitude. Which one's the amplitude? The number in front of cos. Yes? Now, how do we get extreme? Remember, start with the center at 2. Your extreme will be +4 to get to the upper extreme, -4 to get to the lower extreme. So your extremes are -2 and 6. Get the idea? So use the amplitude to get the upper and lower extremes. And then next we're going to get the period. The period can be found by using this number here. 2 pi divided by 2. So the period of the motion is pi. Okay, so once we do this, we can find out the initial position. That's when we make t equal to 0. Notice that it will not start from the extreme because we have an extra pi over 3 there. Okay, so let's work this out. So x equal to 2 plus 4 cos 0 plus pi over 3. Now, if you know your exact value, that will help you to do it quicker. Cos pi over 3 is half. Half of 4 is 2, so it starts at position 4. So it didn't start from the center, doesn't start from the extreme. It starts from somewhere in between due to the fact that there's an extra pi over 3 there. Okay. All right, then we can answer some question about the motion. The first question is, find the first time when the particle is at the center of motion. So what you do is, center of motion is 2. So you write 2 equal to 2 plus 4 cos 2t plus pi on 3. And then we'll solve for t. So we go subtract 2, subtract 2. Like that. Divide by 4, you get 0. So you got cos 2t equal to 0. Now to solve this equation, make sure you remember the graph of cos when it's a 0, when it is pi over 2. So that thing equals to pi over 2. Right? Now you don't need the other one because the question says find the first time. So the first time is you take the lowest number, first time. So you only take the smallest one, so pi over 2. Continuing, 2t plus pi over 3 equal to pi over 2. 2t equals to pi over 6, because pi over 2 minus pi over 3 becomes pi over 6. So t equal to pi over 12. So after pi over 12 seconds, it has returned to its center position. Actually, not really return, but going to the center position for the first time. Okay, try to do the next part. Find the velocity and then find the time when the velocity is first maximum. Okay, have a try. So to find the velocity, make sure you differentiate x. X equal to 2 plus 4 cos 2t plus pi over 3. All right, differentiate it. Okay, let's differentiate. So x dot, or just v, equals to 0 plus 2 times 4 is 8, negative sine 2t plus pi over 3, which simplified to be negative 8 sine 2t plus pi over 3. That's your velocity. Now, what do we do with it? We're going to answer the second question. You say, find the time when the velocity is first maximum. What is the maximum velocity? Well, to answer this question, if you look at this graph, the amplitude is 8, isn't it? So the maximum velocity must be 8. So you do max velocity, you can find from the equation just 8. You don't have to do any special things. And then you're going to solve this equation. Negative 8 sine 2t plus pi over 3 equals to 8. And then just solve. So sine equal to 2t plus pi over 3 equals to negative 1. And then you're going to now, that's negative 1. Remember, you have to draw the graph of sine. Negative 1 at 2 pi, pi over 3, 3 pi over 2, at 3 pi over 2. 3 pi over 2. Okay, so this bit is 3 pi over 2. Like that. And then you solve for the time. So the time will be 2t equal to 3 pi on 2 minus pi on 3 using your calculator. So you do 3 over 2 divided by a third. 7 pi on 6. So therefore, t equal to 7 pi over 12 seconds. So it has reached maximum, the first time you reach maximum velocity after 7 pi over 12 seconds. That's the first time you reach maximum velocity. Okay, good. We'll do 2 more examples, then we're done. Then you do the exercise. 2 more examples. All right, good. Let's move on. Thank you. Example 3. All right, the questions say, a particle moves in a straight line. Its position at any time t is given by this formula. Show that the motion is simple harmonic. Every time the question says show the motion simple harmonic is to show that the acceleration is equal to minus n squared x minus c. That's what you have to do. So we're going to do that. So let's differentiate it twice. So write x equal to 3 cos 2t plus 4 sine 2t, right? And that becomes, if you find v is equal to negative 6 sine 2t plus 8 cos 2t. That's v. And then to get acceleration, you get negative 12 cos 2t plus minus 16 sine 2t. Like that. And you'll notice that you can always take out a common factor, which is negative 4. 3 cos 2t plus 4 sine 2t. And then this is exactly equal to x. This x. Okay? So therefore, the acceleration is equal to the negative 4x, where the center is at 0, right? Because it doesn't have a minus c there, c is just 0. So you can say, so you write conclusion, therefore you say, therefore, motion, you can use the shorthand for simple harmonic, is simple harmonic motion. And the reason why you say, because the acceleration is proportional to the displacement about x equal to 0 in the opposite, because there's a minus, in the opposite direction. Okay, it's very important you write it's proportional displacement about the center in the opposite direction. Okay, it must have an opposite, so it must have a negative. So they're going in opposite direction. So if the displacement is positive, acceleration is negative. If the displacement is negative, the acceleration will be positive. Okay, so that's how we show motion simple harmonic, by differentiating twice, writing in terms of x, and also write a conclusion statement. Acceleration is proportional to the displacement about x equal to 0 in the opposite direction. Once you show it's simple harmonic, then we can answer a question about the center of the motion, the amplitude, the extreme of the motion, and the period. Okay. Now, we'll be able to find two things at this point. From this equation, we could see that n squared is equal to 4, n equal to 2. So therefore, I could work out the period first. So the period is 2 pi over n, 2 pi over 2. The period is pi. So we can work out the period from this acceleration in terms of x. And also from this, I could also work out the center of the motion, which is 0. Okay? Because there's just x minus c, c is 0. The two things we can't work out is the amplitude. And we can't work out the extreme because we don't know what the amplitude is. So if we know the amplitude, I could work out the extreme. So how do I work out the amplitude? Because the equation is not the form we have. Let's write it down again. Cos 2t plus 4 sine 2t. It is simple harmonic, but we can't see the amplitude. So what you need to do is, if you remember the auxiliary angle formula, this can be written in the form of r cos 2t minus alpha, where the r is the amplitude. And there is a simple formula to do that. R is the square root of 3 squared plus 4 squared. So the amplitude is 5. Okay? So you have to recognize this form and be ready to change to another form. Do you need to find the alpha? No, because you don't need to find the amplitude, just the R. And the extreme is, once you know the center is at 0, the extreme must be 0 plus 5 or 0 minus 5, which is just 5 and negative 5 are the extremes of the motion. All right, any question? So things that you learn about trigonometry are now applied in this topic. This topic has a lot of trigonometry in it. Okay, next we're going to find the greatest speed. Okay, so at the bottom, probably I left too much space. Let's do it on the top. Greatest speed. How do we get the greatest speed of the motion? You get the velocity first. So maybe it's better to work with x equal to 5 cos 2t plus alpha minus alpha. Okay, and then we're going to find v equal to negative 10 sine 2t minus alpha. Notice that I don't need to know alpha to differentiate. I could just differentiate without knowing alpha. Now, what's the greatest speed now? The greatest speed must be, the greatest speed is just the amplitude. Because if you draw the graph, that's the maximum value of the function. And it is at, don't say units. Okay, greatest speed. Okay, good. Meters per second. All right, one more example, then you can start the work. Example 4, when you're ready. All right, good, let's move on. Okay, next one. All right, we've got another equation that have a square on it. We have to prove it's simple harmonic. Let's write it down. X equal to 2 cos square 3t. So what do? We have to differentiate it. Before you differentiate, write it as this. We have to use the chain rule. So we do v equal to 2 times 2 cos 3t to the power 1 times derivative of cos, which is negative sine 3t times 3. We have to use chain rule 3 times, differentiate the power, differentiate cos, differentiate 3t. So you end up getting negative 12 cos 3t sine 3t. And then we have to find acceleration. X double dot. You have to use Pascal rule. That's your u, that's your v. Let's use product rule. Differentiate u dash v plus uv dash. U dash is positive 12 sine 3t times 3 times v, which is sine 3t, plus u, negative 12 cos 3t times the derivative of sine, which is 3 cos 3t. Let's simplify this, which is equal to 6 sine square 3t sine square 3t minus 36 minus 36 cos square 3t. Okay. Now, this is going to be a bit more challenging to write it in terms of x, because x is 2 cos square 3t, isn't it? So what you need to do is to change the sine square into a cos square, right? Which is 1 minus cos square 3t, right? Using the trigonometric identity, minus 36 cos square 3t. So we keep going. That will be x double dot equals to 36 minus 36 cos square 3t minus 36 again, cos square 3t, which is equal to 72, or 2 times 36 times 2. 36 times 2 cos square 3t, which is very long. But the good thing is this is x. That's your x. Right? That's your x. So you can write it as 36 minus 36x, which is negative 36, x minus 1. We got it. Therefore, it's simple harmonic. So you can say, therefore, it is simple harmonic motion. So you have to write it in the form of negative n squared, x minus the center. So from there, I could work out what the center is. The center is at 1. Okay, take note of that. A lot of working. Product rule, chain rule, then write x, and then you have to change cos square into sine square into cos square. Yeah. Okay, see you then. Alright, from there we can work out what the center is. What's the center? Center is at 1, and the period is, that's equal to n squared is 36, n equal to 6. So we say the period is 2 pi over 6, which is pi over 3. So from this equation, I could only work out the center and the period. I won't be able to work out the amplitude and the extremes. So we need to go back to the original equation. So amplitude is certainly not 2, okay, because there's a square there. So what we need to do is to change this cos square into a function without a square. So what do? There's a formula we just discussed at the beginning. Cos square theta is 1 plus cos 2 theta on 2. We use this formula. So we're going to do 2 times 1 plus cos 60, because you have to double the angle, over 2, which cancels with this 2. So the amplitude can now be found. In fact, I've written in this form. Can you see this is like the center? And now the amplitude is more obvious. What's the amplitude? 1. So the extreme can now be found. The extreme will be 1 plus 1, 1 minus 1. So the extremes are 2 and 0. So in order to work out the amplitude and the extreme, you must write it in this special form. No matter what form you start with, you have to write it in this standard form. The standard form, okay? Standard form. The standard form means you have to write it in terms of x equal to a cos nt plus c, or x equal to a sine nt plus c, in order to work out the amplitude and the center. Now, what if we did that earlier? Does that actually help us with part A? Yes, it will, because differentiation will now be much easier. Let's try. V equal to negative 6 sine 6t, and then do that again. Negative 36 cos 6t is acceleration. This is equal to x minus 1. No need to use product rule, no need to use chain rule, no need to do anything. So, as you can see, the importance of knowing this trigonometric identity, very important. Okay? Alright, so you're going to go away to do some practice with the Cambridge textbook, which is the best book on this topic. Forgot to give her this. Okay, anyway. Let's finish that.